presentation today is LIT, a domain model library for FHIR with Hugh Simpson.
Afternoon. So I started using FHIR about 2.5 years ago now, and the very first thing I started doing with it, as you might expect with any new unfamiliar technology, is to try and write some code around it. I started off trying to make a naive object, and I cannot apparently advance my slides. Here we go. So this is a slightly dummy example. Let's say I'm trying to make my first ever FHIR object. I'm going to make an observation because that sounds, quite medical. It seems like the sort of thing we'll want to do a lot of. So I'll make a new observation, and if I try and set an effective true, I've looked at the profile. I know that effective can take some sort of type that has a range of possible options, and one of those options is a Boolean. I'm wrong. It doesn't compile. This is the sort of thing that you'd hope for from pretty much any library, right? It should have some sort of this is on the JVM. I should be very, very clear here. If this was Python, I'm sure it would be a very different situation. But on the JVM, you'd expect to get some sort of error if you put the wrong type in. So what it tells us is that we need a model type. So let's wrap our Boolean, and now we have a Boolean type, which is a subset of model type, and it compiles. But if I try and run my test, I get a runtime error. It tells me that this is the wrong kind of model type. Okay, so let's have a look up the profile. We'll try and set the right kind of model type. So here we've got a date time. This one is valid for the effective field of a happy observation, and it's happy. We can serialize this event, and we can send it off. But that's not great, because what we've created here is an invalid observation. It's only got one field set. It's got effective. It doesn't mean anything. This is not helpful. So what could we potentially have done better here? Could we have had some sort of field validation telling us that we're missing required parameters of the observation? Maybe a little error message when we try and compile it saying you haven't specified the code and the status. Could we have had some sort of validation that the type that we'd set for our effective field was one of the right things, telling us that a Boolean is not one of these things. The actual valid one here are the date time period, a timing, or a zoned date time, which is in this instance LIT's representation of an instant. And this whole Boolean type thing, it makes me a bit uncomfortable. A Boolean is a pretty simple thing. I like the idea of being able to just deal with it naturally. And having to wrap it in a new Boolean type just feels like a little bit too much ceremony. So maybe there's something else we can do better here. So, yes, LIT is my attempt to improve on these things, to give myself a library that had the properties that I desired. So if I try and compile this so this is how you might attempt to construct an object in LIT, and that won't compile, and it will give you the error message, unspecified value, parameters, code, status, because you need those for an observation. If I try and pass in an invalid choice type, so we'll set the status, we'll set the code, and we'll try and set the choice to be true, then we get a fairly unhelpful error message, sadly. But at least it does give us an error, and it doesn't compile, and we haven't made that mistake. And as far as the wrapper type goes, it's slightly less ceremony. So we have this choice method that we're calling here, and that will work for any of the valid types. So there's a little bit less ceremony. It's still not directly putting in the type. That's partly because this was written with Scala 2. In Scala 3, you get union types, so that would perhaps have worked a little bit better. But that would have made it a lot harder to interop with Java, which we'll get onto a little bit later. So we started from scratch to try and give ourselves a slightly nicer experience. We thought, what else do we want from a library? So FHIR defines an observation. And then we have various extensions of FHIR. So US Core will define a BMI, which is a type of observation. And implicitly in FHIR, we have this sort of single base type, and that looks a lot like inheritance. So we thought, can we make that work? What we've got here is the same thing in a way. We've got an observation which is actually a BMI observation. And then underneath it, we've got what if that BMI was actually a class itself, because that's already represented. So what's the difference between these two things? They look pretty similar. So the subject field is not optional in a BMI. So if we go back to this, you'll see the subject is just a patient reference for the BMI one there. But it's some patient reference to the observation. That difference in the constructor is sort of distinguishing there between what's optional and what's not. We've got the value field, which is not only non-optional in BMI, it's also necessarily a quantity. So if we go back here again, we've got some choice, some choice of quantity in the observation, but in the more specific BMI, we've just got the quantity directly. We've also got, skip over sort of the effective, that's pretty similar. The meta.profile, I specified that in my observation, but I haven't specified it in the BMI. And that's because that's automatically set by lit, and that's actually what enables it to decode into a more specific type. Otherwise, anything that it received over the wire would have to be decoded to the base resource type. By using the meta profile, we can be more specific and have something that's more refinedly typed when we decode. And then the last one is perhaps a little bit harder to spot. So the category is non-optional in BMI. And what would actually happen if I've given a value to it. So lit sec is this sort of listy type that lit has. And I've given it a value here. What would have happened if I attempted to compile it without giving it a value? Is it wouldn't have compiled. So there's a distinction in the library between a non-empty list and an empty list. We don't have any further refinements of cardinality. In our use cases, we've never come across any reason to have, two or more, or one or two. It's always can be empty or can't be empty, at least in our experience. So that's the only sort of support we have for cardinality is just that.
Would you like to ask questions?
I assume so.
In the list of differences, I was thinking maybe you would say something about supplying the observation.code. I don't know if it's literally a fixed value or it comes from a limited set, but how do you think about that?
Oh, the code, yes. So not everything that could be fixed is fixed. So there are things that I would like to do with the library that I have not yet done with the library, and that is one of them. So the code, could for many profiles sort of be set automatically as well, and that would be nicer. Oh yeah, please.
And another case that I might have missed, but it's hard to fix, is where a element that repeats is constrained to 1-to-1, right? So it becomes non-repeating. Is it still a list, or it would be ultimate if it would turn into a single value? Right.
So if a list is subtyped to be 1-to-1, then the constructor, you would pass in just a single object. But let's get to the gotchas on this, because we do have to make some compromises. If the BMI extends an observation, then when you access the field, it has to have the same type as the parent. So in that sense, the fields don't necessarily fully reflect what you pass to the constructors. For that reason, we do have sort of extractors. So in Scala, this is represented on a companion object. You can think of that as just being a static method that enables you to sort of extract the more refined type of the field. So for BMI, if you call BMI.extract value, that will only take a BMI type, and it will always return sort of the more refined types, in this case, a quantity. So we thought, okay, what else might we want? some sort of meta information so that we can reflect a little bit on the structure of FHIR from within the type system. So what we've got, it's not necessarily the prettiest thing in the world here, but like say we wanted to get a list of non-optional field names. Then that's something that we can do by accessing sort of the field metadata on the BMI companion object. Again, if you're not familiar with Scala, it is basically just the same thing as static fields on a Java class. Some sort of transformations. So if we are, let's say we're a projector reading from one pipeline writing to another, and we know that one of the client apps has been sending the wrong code. It's got the wrong semantic type. We just want to change it from A to B so that our consumer downstream is getting the right thing. Then we can sort of map across any coding and say, if the system is this and the code is that, then set that. So and extractions to be able to say, okay, what are all the codings in this bundle? So what do I need to care about? And one thing I've sort of I should definitely have put on this slide is that the library fundamentally is an immutable model. So all of these things are creating transformed versions. You cannot mutate the underlying object. And what cost? So this is object construction duration. We've got, I'm benchmarking here, pretty loose benchmark. This is not the most refined ever. But so we've got lit, happy, and then FHIR proto, and they're all pretty similar. You might ask me why benchmarking object construction, because that seems like that should be pretty light. The reason is it did suck at one point. So when we spotted that, added some benchmarks for that. And then more obvious choice, JSON round trip encoding and decoding. This is really unfair to FHIR proto because it goes via proto and then the JSON translation. So that's not really what you would expect to use FHIR proto for. Oh, so I'll move a little bit closer to the mic. Okay, I'll take that on board. So yeah, the runtime performance is actually fairly comparable to the other competing implementations on the JVM. And I have been talking about this from the perspective of the Scala API. There is a Java one as well. It has to be slightly different. So in Scala, you have named parameters with default values. That is not something you have in Java. So in order to be able to reflect the optionality and non-optionality of parameters, we have builders that will take a sort of a init method that takes all the required fields, and then additional sort of fluent DSL style for setting optional fields. There are a few other differences. In terms of the choice method, that's impossible to implement in Java. It cannot be done. So there are some sort of named wrappers for that, sadly. There is a little bit of limitation to the model introspection. So if I go back to this slightly funky looking construction here, these LTT things, that's a type tag, that's not constructible in Java. So you miss out on some of the things that you can do with that. And the lack of implicits and macros just generally makes things slightly clunkier. Most of the things that we do in practice with this library can be done just as easily in either language, but there are just a few little things that don't quite work. So there are plenty of things that are the same. The litsec, that's inherits from the Java util list and some of the base Scala collection methods. There's some slight incompatibility. It can't be both a Scala and Java list, but we tried to get as close as we could for compatibility on both of those. It's immutable from the perspective of whichever of the two languages you're using. The required params are guaranteed to be present, and obviously the inheritance and all of that is the same underlying model. So there's slight differences in the API, but fundamentally the same. And additionally, you can generate these as well. So we have got a published version which is sort of the base HTML7 spec, and another module which is the US core. But the generator is also open source. You could feed in your own profiles and generate a class model from that if you so chose, and that will generate both Scala and Java. There are some gotchas. So there's a little bit of startup time penalty, about maybe, it depends on the hardware you're running on, right? But like maybe an extra couple of seconds whilst it initializes itself. There is a compile time penalty, especially if you're using the Scala DSL, especially if you're using it from Scala, because there is a bit of overhead as it sort of figures out whether a choice is valid, for example. So there's a little bit of computation it has to do. And if you are using native image, you will have to provide a little bit of sort of reflection configuration. We do use this with native image. It's perfectly usable, but you just have to configure a little bit extra. And my company wanted me to put this slide in. And that's that. I can take any more questions.
So I wrote the code generator for the .NET stack, so I know a lot of your pain. One of the things is, of course, the value X, where X, you know, the choice types, where the choice is limited. In Scala, there are discriminated unions. Is that what you showed, or?
So in Scala 3 there are,
Okay.
but this works with Scala 2. And actually it's quite sort of implicit heavy, but essentially we were able to sort of figure out a way of getting the compiler to, using just the type tag, determine whether the value that was being fed in was actually valid. I don't really want to go into the implementation of this too much right now,
No,
because I did not bone up on it.
No.
But suffice to say, I was very, very, very smug about getting that to work. And it's not something that you can really do in Java at all, because you can't. So Scala allows you to just sort of compile time proofs. You can say, I will compile if I can find a single value that fulfills these conditions. And then you can also have a method that will be able to construct such a value if other conditions are met. And using that, it's just essentially a sort of cons list of the valid values. And the compiler is able to sort of figure that out.
Uh-huh.
In Scala 3, it's a lot easier. We just use the unions that they provide us in the language.
Sure. Yeah, so one of the things I considered ever was, you know, creating unions for each combination, because that's the only thing I can do in C#, right? For example, and because if the runtime type system, and I don't know, I know from the .NET, I don't know in Java, but there is no support for discriminating unions. So I'm pretty sure that if I work in F#, for example, where the language that does have discriminated unions, it actually just generates the class for it. So that would basically have been the same thing if I would generate all the combinations. And when I saw that error with, you know, union 6843 in your error, I was like, see, you've been generating unions there.
Yeah, actually that one only happens because there's 4 or more valid types for that. If there's sort of 2 or 3, it'll be, you know, period or date time or what have you. But at a certain point, that starts to be quite long and unwieldy as a type name. So we just.
I would say, I mean, and I did wonder why I didn't use an implicit cast to get the true to a FHIR Boolean, because I have the same thing in the .NET library where you have to construct a FHIR Boolean of true instead of supplying a true. But I think .NET, maybe Java has you can define your own, you know, user-defined conversions, which would have allowed me to remove that little bit. But well, I think most of the time, if I'm ever going to redo it, I can't redo what I have because there's like a decade of code written in it. But I certainly want something that also fits. You know, I think most people are now interested in generating classes for US core, just like, you know, like you were showing with the right fixed code. So if I'm going to do this ever again, it probably has to incorporate all that kind of stuff.
Well, that's actually so we've got four modules that represent parts of the domain. We've got the core one, which is just everything you need to be able to do extensions. And then we have a sort of HL7 one, which is the main spec, and then US base and US core are the other ones. But internally, we have another repo that uses our own profiles as well. But we figured that was probably less interesting to the open source community than the HL7 specs.
Yeah. There is one question online before we close, as we are at time. Do you plan on supporting any more languages?
Yes, absolutely. This was originally part of the vision of it. It sort of got a bit on hold, but there is some work towards supporting TypeScript and some work towards supporting Rust. Those are two of the three that we'd most want to support, the other being Python, but there's not really been any work on Python yet. We ended up just sort of maturing the support for Scala and Java in preference of supporting additional languages. We figured that would sort of make it easier for us to let's say clarify our ideas. We wanted any additional languages that were supported, we wanted them to look similar, otherwise sort of what's the point?